the cam portion for the part called holder, 8DV4700303. Okay, this part has features on several sides. There's different approaches you could take. We are going to be needing to machine these threaded holes. It'd be nice to get these chamfers in, and we've got a cross hole here. One note, we are going to have to add a tool, and we'll be doing that in the tutorial. We're going to add a drill to drill this hole. It's not reflected in the permanent library. We'll consider that a special tool, so we'll be adding that. All right, there's several ways to approach this. I'm going to elect to approach this by having the part as facing as it is, with the bottom attached by the dovetail. That'll allow us to profile these features here, and we should be able to get access to everything. Let's draw our stock. I think the easiest way to do that on this one is we look at the bottom view, and we're going to make our sketch on the bottom of the part, and we're going to do a rectangle, and our bar stock size we're using on this one is 2.5 by 1 inch. Okay, if I had some options of other material, we might make this a different way, but so the faces that we're going to mill our dovetail on is going to have the saw cut face on it. All right, so now we need to center this. I'm going to draw a line that's horizontal. I'm going to right click on that line and turn it into construction. It's constrained on the left side to midpoint, and then we're going to do the same thing for the opposite side of that line there. Okay, and then we're going to draw a line from corner to corner. And then we align the midpoints, and it should center. Okay, we're going to go look at the part, and we're going to do an extrusion in 2 directions. So again, we want as much material on the dovetail side. So I'm going to hit finish sketch, and we're going to do an extrude. So we're going to select our extruded areas, and we're going to change to 2-sided. And in the one direction, we're going to go a distance of 20 thousandths. And our overall height of the stock is 1.25 inches. So we're going to put in minus the 20 thousandths, 1 inch, 230. And we need to change this to a new body, otherwise it's going to cut our part away. And that should net 1.25 inches from one end to the other. So let's hit OK. Go to our bodies. And again, you want to name the actual part with the part number, and we're going to call the other body stock. I'm going to right click on stock and go to opacity control, make it about 50% so we can see through it. And let's just double check the overall height of our stock. So yes, it's 1.25 inches is what we start with. Okay. Now we need to put our dovetail on this. So we're going to look at the end view, and we're going to put our sketch on the end. And this should be routine by now. We're going to go from edge in, we're going to angle down for our little flat, crossed, up again, angle, and then making sure we attach to the opposite end. We want to do equals on the lengths of our flats and on the length of our lands. We also want to make the lands collinear. We want this whole pattern centered. Okay, we're going to go line from center of our dovetail to center of our stock. We're going to right click on that line we just created. We're going to make construction, and then we also are going to make it vertical. And that'll force this to be centered. Now you notice my dovetail just canted to the side. That's because I didn't constrain this line here horizontally, but now it is. Okay. All right, now we can switch to dimensions. Okay, so we're going to dimension our angles. So both sides are 45. We'll dimension the little flat here. That is 10 thousandths according to the spec drawing. And then we're going to put 20 thousandths between that shape and the edge of our stock. So we have material to remove. And the spec drawing says that this land needs to be 1/4 of an inch minimum. So we will do that. And then from the land to the top of the dovetail is 80 thousandths. Okay, so we have our profile we should be able to cut. We're going to finish sketch. We'll do our extrude. We're going to pick on the volume we're removing. We're going to cut. Let's look at it in a 3D view. We're going to go to distance to all, so it's going to go all the way through. We need to flip sides, and it renders in red what's going away. Hit OK. So there's our dovetail to clamp the part into. Okay. That's creating the stock, and we're ready to go to start programming. Let's go over to the Manufacture tab. Okay, and we're going to set up our dovetail machining. Again, this should be something that you're able to do on your own, but I'm going to go ahead and do go through the motions of the programming. We're going to create a setup. And on this one, we are going to use, again, relative size box. Relative size box, we're going to add stock to all sides. In reality, we're leaving 0 on all of the faces except for the z-axis positive. We're going to put in 0.02 because that's how much material we're removing. Let's go to our setup. We're not going to go off model origin. We're going to do z-axis plane and x-axis. So select the top of the part. That shouldn't change anything. And then our x-axis is one of the horizontal lines. Flicks our x-axis where it should be. And we should select the model. You may have yours auto-selected, but the actual part that we're cutting, in this case, it should be the stock model that's selected as the body. And we can minimize fixture. We're not using that. Okay, so my box point is, if we're using parallels, and bottom left corner is going to be the back left corner of our stock. Alright, let's go to the Post-Process tab, and we're going to stick with our naming convention 3031. It's the first program for the part ending in 303. Op 1 for the VF, split VF, stock rep. Okay, and we can use work coordinate system 1 or 0. It's going to output the same thing for Haas, which is 54. Hit OK. I do like to change the setups to match. So this is our op 1. Alright, I'm going to use a 1/2 inch end mill because this, instead of a face mill, and this is such a small part, we'll use the 1/2 inch end mill to deck the top down and cut down to this plane. That'll also ensure it's the same tool cutting both planes. So we'll have an accurate 800 thousandths height. We're going to do a face mill. We're going to select from the VF library our 1/2 inch end mill, which is tool number 2. I'm going to take the default C's and speeds. Multi-axis, we don't do anything. Geometry, we have our auto select, which is fine. Heights tab, most of this we can just leave it default. Our default step over is 350 thousandths, and our pass extension is a little bit of a 1/4 inch. I'm going to bump up the pass extension. We're going to go 0.03 or 0.3, just a little bit farther than half the diameter. And our step over again should be 80% of a 1/2 inch for traditional machining. Use our calculator. 25 times 0.8. It's a 400 thousandths, so we can go a little bit more than what the default was. Okay, we don't need to do multiple depths. We're not leaving stock to leave. We're going to move to the next tab, linking tab. Let's leave everything at default except for, as you know, I don't like the vertical lead in on much of anything. So let's hit OK. Alright, so we got our face mill using the end mill. It's a couple passes there, but it should be pretty quick. Now we're going to take that same tool and we're going to do a 2D contour. We're going to select the bottom edge of the flat on the dovetail. We're using the same tool, so the feeds and speeds will stay the same. On geometry, we've gotten that. Heights. We're going to go to stock top now instead of model top. And for our bottom height, we're not going to selected contours. We're going to select how deep we want to go, which is the face of the land. On the passes tab, we are going to do roughing passes. We can leave the step over at default. We're going to do one roughing step over. But we want to go up to the step over box and we want to make that 10 thousandths. For how little we're taking off, we're not going to do multiple depths. Okay, we're going to go to the linking tab. We are not going to approach at 90 degrees. We're coming in on the end. We're going to lead in off the material. So we're going to put 0 here, but then our lead-in distance needs to increase to more than half the diameter of the cutter. So let's just go with the same 0.3. And I'll make sure we're leading off, and if our stock's a little bit bigger, we got a little bit of extra room. And we're going to get rid of our vertical lead-in radius. Then we go to the linking tab, and we hit OK. Alright, so we should get a roughing pass and a finishing pass. Alright, next tool and final tool for this operation is we're going to do the contour for the dovetail. So we're going to do another 2D contour. We're going to pick the vertex of the dovetail from both sides. Make sure your arrow's on the right side. You notice I rotate and I pick where I want the end mill to start. That tells Fusion what side by default to put the arrow on. If you do have it on the wrong side, just pick on the arrow itself and it'll flip. Alright, so we're going to go back to our tool. We're going to switch to tool 19, which is our dovetail cutter. And we'll take the default settings for feeds and speeds. We got our geometry already selected. Our heights again are going to be based off model top, not stock. And we are, in this case, going to the selected contour. Under passes, we want to have wear compensation in case we want to use cutter comp. I'm going to slow the finish feed rate down to 20 on this. We are going to do roughing passes. 1 is fine. And that makes the step over box show up. And our step over is going to be 10 thousandths. We go to our linking tab. Again, we're going to go to 0 degrees sweep angle. And our linear lead-in needs to be more than half the diameter. This one's 1/4 inch also. I'm sorry, 1/2 inch also. So the radius is 1/4 inch. We'll go 300 thousandths with no vertical lead-in. Hit OK. And that should result in 2 passes. Do our finish cut. Alright, you're done. You should be done with this operation. Now we'll move on to the 5-axis. Alright, so let's visually flip this in the orientation it would be on the machine. We clamp our block in the vise. And I'm actually going to rotate it this way as our first orientation. That way we're seeing this feature on the right when we're setting up. Okay, we're going to create a new setup. And on this setup, we are going to have the model is going to become the part itself. And on stock, we're going to select from solid. And we're going to pick the stock model. Now we're going to set our orientation. It's not going to be model orientation. We're going to go to Z-axis and X-axis for our neutral plane. We'll pick on the top of the stock. And our box point will be the center of the top of the stock like we've been doing. So we'll probe that location. And then we don't need the fixture controls there. And then we go to post-process. We're going to call it the 303.2 op 2 for the UMC 750. And we're going to use offset 1. For this project, you guys have been through the routine a couple times. I'm not going to bring in the vise fixture in the video. I do recommend you reference the previous videos and bring in the vise fixture just for your setup images. But I think you've been through this at least 2 times now. You should be able to reference the other videos on how to import the 5-axis system vise. It is helpful to show it in your setup sheets. So, let's hit OK. We're going to change this to op 2. Okay, so the first thing we're going to do is we're going to lop the top off of here with the face mill. It is a small part, so probably should just take the same approach we did with the flat end mill instead of using this big 3-inch face mill, which will put a lot more torque on the part that's being held on by a dovetail. So we're going to go to face mill. We're going to switch to the 1/2-inch end mill. But we want to make sure we're selecting it from the UMC library. It is different. Okay, even though the tool number is the same, the geometry is similar, the holder and length offset is a little bit different. Okay, so we've got our end mill. We're going to take our default feeds and speeds. That geometry is fine, but we want to cut to the actual model itself. So we're going to go to the heights tab and stock top. stock top, but our bottom height is going to be model top. Okay. Now we go to the next tab in our passes. Our pass extension, we're going to go 0.3. Step over a 350 thousandths is fine for this. Maybe we take a little bit less aggressive cut because our work holding is not as rigid. We go to the last tab and we're going to get rid of our vertical lead-in radius and hit OK. Alright, it generated almost the same toolpath with that side step over. Okay.